Hi, this is Professor Evans. This video is for EET 1214C, and in this video I'm going to go over Lab 4, which is DC circuit measurements. We're basically going to build a series DC circuit and learn how to measure the total current, the voltage across each resistor, the total resistance, and the resistance of each individual resistor. So I'm going to start this experiment by locating my 330 ohm and my 680 ohm resistors. And I'm going to measure the resistance of each resistor just to verify that it is within tolerance before I start. So I'm going to begin by getting a black alligator clip and a red alligator clip and connecting those to the DMM. So here's my red. Here's my black. I'm going to turn the DMM on. I'm going to set it to measure resistance by changing the unit to ohms. And then I'm going to connect my first resistor and verify its level of resistance. This is my 680 ohm resistor, and I'm getting 0.676 kilo ohms or 676 ohms. I'm also going to verify that my 330 ohm resistor is within tolerance. All right, I've got 0.328 kilo ohms. Remember to check the unit there, or 328 ohms. So both of my resistors are well within tolerance, and I can use these to wire my circuit. Next, I'm going to place the 330 ohm resistor into the breadboard. You can pick any two separate rows that you want, because remember, the rows are connected this way, but not this way. Remember, there's also no connection across the Great Divide in the middle of the breadboard. Now, if you look at the circuit provided in your lab manual, you'll see that this is a series circuit. So current has to travel through R1 and through R2 before returning to ground. So when I add R2, I'm going to make sure that there is a connection point for circuit to flow through R1 and then through R2. In order to do that, I'm going to make sure that R2, my 680 ohm resistor, shares a row with the right leg of R1. So I'm going to make sure that as I put this second resistor in, these two legs here share the same row. That way, as current travels through the 330 ohm resistor, it has a place to go and will then travel through the 680 ohm resistor. Lastly, I'm going to connect the 680 ohm resistor to ground because I only have two elements in this circuit. So I have my 330, I have my 680. Now I need to connect my voltage source and complete the path for current to flow. To add my voltage source, I'm going to use the triple power supply, which looks like this. It has three separate terminals to give you various voltage levels. The terminals on the left and the right will give you anywhere between 0 and 20 volts. You'll see that measurement right at the top. The terminal in the middle gives you exactly 5 volts. So if you need exactly 5 volts, you can use the one in the middle. If you need something other than 5 volts, you want to use the one on the left or the right, and you'll turn the knob to set the level of voltage. So I'm going to get a second set of alligator clips, one black, one red, and connect that to my triple power supply. Now I'm going to supply power and ground to my circuit. So I'm going to supply power to R1 by connecting it to R1, just like that. So current is going to leave the triple power supply, flow into R1, through R2 because they're connected right here, and then we have to add our return path to complete the loop. So I'm going to connect our black or ground probe to the bottom of my circuit so that current will flow out of the red through R1, through R2, through the black, back to where current started. Now we have a complete path of current, a series path of current. Now I'm going to go ahead and turn on the triple power supply and set my voltage to the appropriate level. According to the lab manual, our voltage level should be at 15 volts. So I turned it on and I have 5.4 coming out of right here. This display is for this terminal. This display is for this terminal. So I'm going to use the knob to increase this to 15 volts because that is what is in the lab manual for this experiment. Once I've turned the knob and set the voltage to 15 volts, Everything is set up. There's one final step though. Current doesn't actually start flowing out of the power supply until you hit the output light and this light turns on. So very important to remember, if this light is not on, you don't have any current flowing through your circuit, and if you try to take a measurement, you're not going to see anything. So you want to make sure that the green light is on. Now we have current flowing through the circuit and we can take some measurements. We're going to start by measuring the total current in the circuit. To do that, you're going to need a jumper wire. When we measure current, we break the circuit, and that's because we have to insert the DMM in series with the path of current. So I'm going to break the circuit by removing the power. So I'm going to remove the power source, and I'm going to place a wire in the same row as where the power source was. Next, I need to direct the current that is coming out of the triple power supply through the DMM, out of the DMM, and then back into my circuit. So I'm going to take my other two alligator clips that are connected to my DMM. I'm going to connect the red alligator clip where current would have entered the circuit. Well, current is going to come out of here to enter the circuit. So I'm going to direct all that current now to go through the DMM. It's going to follow this line. So current is going to come out of the triple power supply. It's going to go into the DMM. It's going to come out of the DMM. It's going to come out from this alligator clip, and now I'm going to send that current through the circuit. This is what we call breaking the circuit. We're putting the ammeter in series so that all of the current is redirected through the ammeter, or in this case the DMM, before it enters the circuit. Now we're going to set up our DMM to actually measure this level of current. To measure current, we're going to take the red clip and move it over to the blue port. You're going to select amps or milliamps depending on what you expect to measure. In this case, because we simulated this in multisim already, we expect to measure milliamps. So I'm going to put this red port in the milliamps. Then I'm going to change the unit by pressing the down arrow until I get to milliamps. And the screen is going to update with my current measurement. In this case, I'm measuring 14.99 milliamps, which is very, very close to the 15 milliamps we expected to measure per our multisim demonstration. Oh, there it goes, 15 milliamps exactly. I'm going to show you again how to break the current using a different point on the circuit. So I'm going to take the DMM out. I'm going to put everything back the way it was. Since this is a series circuit, I can also measure the current from this point as well. Current's going to be the same everywhere. Again, to break the circuit, I'm going to break the path of current flow. So I'm going to pull this resistor out. And I'm going to put a wire in its place. So to break the circuit, you're going to create an open connection and put a wire in the place where you broke it from. Then you have two connection points to connect your DMM. The red port goes where current would come out. So I know current is going to go through here and come out of this wire. The black port goes where current is going to re-enter the circuit, and current is going to re-enter the circuit through R2. So I connect that, and I have, again, my measurement of 15 milliamps for the total current in the circuit. Now that I'm done measuring current, I'm going to put everything back the way it was before I move on to measure voltage. So I've removed my jumper wire. I've taken off the DMM, I've made sure that I've re-established the path of current, and now I'm going to measure the voltage for each resistor. To do that, I need to move my red clip back over to the red port to measure voltage. Now, to measure voltage, we measure in parallel. That means I can take my two alligator clips and just clip them on either side of each resistor. Clip the red where current would enter and the black where current would exit. Current would enter on the left, exit on the right, so I've got my red and black across that resistor for R1. And now I've moved my clip over to the voltage port, and I'm going to change the measurement so that it measures voltage. I'm also going to increase my range to at least 2 decimal points, and I can see the voltage for R1 is about 4.92 volts. I can just move my red and black clips to measure the voltage for R2. Remember to put the red where current enters. Current will enter the top and exit the bottom. So I'll put the red where current enters and the black where current exits, and I'll have my voltage measurement for R2. The last thing that we're going to do is measure the total resistance of the circuit. We learned how to calculate the total resistance of a series circuit by hand by simply adding up all the resistor values. But how can we get a DMM to also give us the total resistance of a circuit? Well, first I'm going to remove the DMM from the circuit. Next, I'm going to completely remove the power source. Completely disconnect it. Don't just turn it off. Disconnect it from your circuit. So I am taking the triple power supply out of the equation. It is completely gone. Next, I'm going to take my 2 alligator clips for my DMM, and I'm going to clip them in place of the power source. I'm going to clip the red where current would enter. I'm going to clip the black where current would exit. And I'm going to set my DMM to now measure ohms. And I'll have the total resistance of this circuit, approximately 1.003 kilo ohms, which is pretty close to what we got when we simulated this in Multisim. So this is how we measure the total resistance. Again, you want to completely remove the triple power supply from the equation because it will give you an incorrect measurement if it's still connected to your circuit in any way. Once you remove the triple power supply, you're going to connect your DMM, your red and black clips, in place of the power supply, where red goes where current enters, black goes where current exits. This is how we complete the measurements for our DC circuit for Lab 4. We've measured the resistance of each resistor, the total current, and the voltage drop for each resistor, as well as the total resistance of the circuit. So please use this video to practice these skills in preparation for your upcoming quiz on DC circuits.